Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, we'll talk about climate adaptation.
Funding for Energy Switch was provided in part by the University of Texas at Austin.
To curb global warming and its effects, most government policies have focused on mitigation, reducing CO2 and, more recently, methane emissions. But there's a growing focus also on adapting to a changing climate. This could include expanding air conditioning, along with passive cooling techniques like urban greening, and engineered and nature-based solutions to counter sea level rise. I'll discuss these and more with two expert guests. Vijay Limaye is a public health scientist and director of the Applied Research Initiatives in the Science Office of the National Resources Defense Council.
Adaptation investments really make a whole lot of sense. Mitigation can kind of seem like, a problem where we can't tell if we're making much progress. Adaptation is different. It's clear, it's local, and it's tangible, and we can feel the benefits.
Susan Asam is a vice president of climate planning and a Climate Center senior fellow at ICF, a global consulting and technology services company.
We absolutely have the tools to minimize suffering. We can do it. We're gonna have to invest. We're gonna have to have people understand that their behavior may need to change, but we can, absolutely.
I'm Scott Tinker, and I'm an energy scientist. On this episode of Energy Switch, a discussion of strategies for climate adaptation.
We're talking about adapting to climate change today, and first of all, why should we even care? Why should our viewers care if we can adapt or not?
We have three choices. We can either mitigate, adapt, or suffer. And we want to minimize how much we suffer, obviously. So first we need to mitigate, and then whatever we can't mitigate, we need to adapt to. And whatever we don't adapt to leads to suffering.
Yeah, that's a pretty good reason to care. Anything to add to that, Vijay?
This is really about protecting what we have and fighting for a fairer, healthier future for all of us.
Yeah, that's a good point. Why have governments focused more on mitigation as compared to adaptation? What do you see there?
I think, for a long time, the idea of adapting to climate change has been seen as giving up. And there's really been an effort to, I think, put all our eggs in the mitigation basket. The truth is, we need a lot more of both, and there's solid evidence showing that preparedness, which is really what adaptation is all about, can help people here and now.
Interesting. Things to add to that, Susan?
Yeah. I agree. When we mitigate, we're reducing greenhouse gas emissions globally, which is very important to us, again, stopping how much we need to adapt and how much we suffer. But adaptation is something that can really make a difference in these communities that are experiencing disproportionately the impacts of climate change. Whereas mitigation, we're really trying to, just stop the contributions globally.
Right. Let's talk about it. Heat. We're warming. We've warmed over 1 degree C now in the last century or so. Where has that mostly been felt
Yeah,
today?
well, just to speak to the U.S., it's getting warmer everywhere, but areas that were already hot, like the southern areas and southeastern parts of the United States, are getting even more dramatically hot. But interestingly, those areas that are already acclimatized to heat don't necessarily have the most impacts when a heat event arises. It's some of the areas like in the Pacific Northwest where they're not used to those high heat events. And 44% of the people in Seattle have air conditioning versus a much higher penetration in some of those hotter areas.
Right. Do you feel that same way then about, let's call it the global south, or those emerging and developing economies? Thoughts on that?
Absolutely. In a country like India, where I do a lot of work, AC penetration is maybe 1 in 10 households right now. We know that India is the most populous nation on the planet. Economic growth is happening in such a way that people want and need access to life-saving air conditioning. The idea behind adaptation is to try to keep people cool and safe and healthy without making the global warming problem even worse. So these, ideas really go hand in hand. We need to be thinking about ways to actively cool people through air conditioning and heat pumps, other, tools, technologies. We also need to think about passive cooling, ways that we can cool down entire neighborhoods, entire cities through implementation of things like urban greening and cool roofs to help dampen the urban heat island effect, this accumulation of heat, especially in megacities around the world, and help people to find some relief.
What's an urban heat island? What is it?
In urban areas, especially where you have a high level of impervious surfaces or concrete, the heat intensifies. There was some work done in Honolulu trying to create a map, and they found in certain areas that there could be a 27-degree swing from morning to afternoon in those areas that were most intensive with the concrete and impervious surfaces, versus like an 8-degree swing where there were places with higher vegetation. So that's a pretty dramatic difference.
Oh, yeah. More to add to that, Vijay?
I would just say that, where these urban heat islands are showing up in the United States, for example, there's plenty of evidence indicating that, a century of redlining, the absence of trees is not an accident, right? And so we have this accumulation of hazards in some urban areas, especially in areas where we have low-income communities, communities of color. And so reshaping the built environment can also correct for some of those historical injustices that have been committed that we're seeing show up in health problems here and now in terms of extreme heat.
You talked about India and the cities there and heat plans. What do you see on that, Vijay?
Yeah, one city where we've been working in Ahmedabad in Western India suffered an intense heat wave in 2010 in which 1,300 more people died during just a few weeks during an intense heat event. And that event in 2010 was really a wake-up call for the city leaders in trying to make sure that early warning systems are set up so that people know that extreme heat is on the way. And it's not just an inconvenience, it can be deadly. Trying to make sure that women, for example, who are often burdened with higher heat exposures, they may have to be dealing with indoor cooking at the same time on a hot day. They may have to be working outside. But we're also thinking more comprehensively, right? Making sure that medical professionals, doctors and nurses are aware of what intense heat exhaustion, heat stroke looks like so that they can anticipate it and diagnose it. Making sure that intensive care units and emergency departments are prepared for an influx of patients. But also thinking more long-term, right? About how to shape the city's built environment. So implementing that urban greening that can help to provide more shade, cool roofs that can help to reflect some of that incoming solar radiation. So that first plan, that first heat action plan in South Asia launched back in 2013. And since then, it's been improved upon and scaled far beyond that one city. So now it's in operation in more than 30 states. And maybe 100 cities or so have their own heat action plans. But this vulnerability point that Susan mentioned earlier remains a weakness in India.
I think heat in particular is a tricky impact. It's not like a hurricane where you can track it, it's going to come in, it's going to move on. Heat is something where over days, the impact gets more and more intense. And people are then facing this increased risk as the event goes on, but they don't have a good sense of when should I do something different.
Yeah, that education, what to do, so vital. Training and education, particularly getting the message. How is that done?
We need to be calibrating these extreme heat early warning systems to really take into account what the local conditions on the ground look like so that people understand that, yes, this is actually a serious situation. You should be, careful. Occupational health and heat, I think, is going to be a big focus of the adaptation needs in the coming years. Agricultural workers who are certainly outside being exposed to elevated temperatures. But it's not just them, right? It's truckers, it's teachers, it's students, it's people in, Amazon, warehouses. It's all sorts of people who don't have the luxury of being in air-conditioned environments.
Absolutely. Teaching workers to recognize the symptoms, when are they experiencing heat stress? What does that look like? And recognizing that OSHA is working on workplace standards, that will really help us to acknowledge the risk and then take action on the risk.
I would think it would improve productivity. At the end of the day, it probably helps companies to...
Right. The cost-benefit stuff, I think is important to think about. There's a study in Australia looking at their heat health early warning system, finding that, the health benefits of reduced trips to the ER or hospital calls vastly outweighed the costs that were involved in just getting the word out about extreme heat risks.
Yeah, that's a good one. Let's talk about air conditioning. We've mentioned it. It is helpful. I mean... Not going to kid you, living in Texas. How do we get more air conditioning in places that lack AC currently?
I still would push us to start by saying, is air conditioning the solution? It's a limited solution. I think there are still a lot of gains to be made in terms of thinking about energy efficiency of buildings, retrofitting buildings so that we're not losing cool air.
Right.
And then with new construction as well, really thinking about how do we design buildings so that they can be not solar radiation are not exacerbating issues, or that, again, wind and ventilation can be really maximized.
Susan's spot on. I think we need to think about AC, but we also need to think about more efficient solutions. Heat pumps, right, are a more efficient solution that don't use the types of refrigerants that are making the climate change problem even worse.
Yeah.
Well, one of the least expensive ways to be cooling buildings is adding shade. And it's something that people have been doing and recognized how cheap it is to plant trees in our urban areas, you know? So I think, again, there are some sort of easy solutions that are not going to be the only solution, but there's a lot of room for improvements, you know, already with very simple solutions that also have all these ancillary benefits.
I love the idea of urban greening. You know, it's for lots of reasons.
Yeah, absolutely.
It makes it prettier, too. Schools and hospitals and government buildings and transportation centers, train stations and stuff, these are bigger things. Yeah, how do we do that?
It's not just in the home, right? So many schools, even here in the US, don't have air conditioning that's functioning. In India, we've been focusing on healthcare settings because, you know, a survey we were part of more than a decade ago showed that maybe 1% of hospitals actually had functioning AC. So we do need to take immediate actions to keep the most vulnerable when they're in a healthcare setting, in a cooler space. So there was work in the city of Ahmedabad, where we've been working for a while now, to basically shift the neonatal ICU ward from the top floor of the hospital, which was the warmest floor, to the bottom floor, right? A relatively simple action that resulted in a significant reduction in heat-related admissions to the NICU, right? So
that's interesting.
There are, comprehensive ways to get around this problem depending on the setting, right? Schools look different than hospitals, look different than transportation corridors, but we need to be thinking creatively about what we can do here and now, even as we kind of gather additional evidence.
I don't think I'm hearing you say, but stop me if I am, you're not saying people can't have air conditioners. You're just saying let's supplement those with things that make it a lot more efficient so that we're not having to use them nearly as much. Is that reasonable?
Absolutely, yeah. I mean, I think air conditioning is similar to planting trees. It is a known solution that can really help. But I think what we've been highlighting is some of the limitations of that solution and some of the challenges associated with it.
Yeah. Do you guys have examples of where this has worked? Points of light, if you will, for some of the solutions we've just been describing?
Yeah, globally, I think adaptation interventions are happening on the ground. We know that there are, tons of projects being deployed. They're not being evaluated as much as they should be.
So it's early stages?
It is.
Okay.
But we have been able to evaluate that first plan I mentioned in Ahmedabad. It does seem like the city is avoiding deaths, especially in the warmest days. It's helping to save people's lives, save them money, and overall improve preparedness on the ground. You
have examples of places this has worked or is working?
I think in the U.S. cities, I think we're still in even earlier stages, frankly, in terms of these heat plans being rolled out. We're seeing chief heat officers being established in cities just within the last couple years. I would say that the silver lining of these extreme heat events we've seen in the past few years is there's increased awareness, widespread in terms of heat events and the heat impacts. But I don't think we've quite gotten to the point where that's translated into implementation of heat plans and all the way to knowing what the results will be.
Yeah. Let's kind of transition to energy systems thinking a little bit. Why is it important to develop or retrofit our energy systems to be heat tolerant?
We know that demand for air conditioning, for example, skyrockets during extreme heat episodes. And we also know that blackouts are becoming more often. We saw from 2015 to 2020, the number of blackouts across the United States doubled. Most of those happened in the summer. If we don't harden the energy infrastructure to be resilient to the influx, the skyrocketing demand on the grid, we have transmission lines that are sagging. We have reduced efficiency in terms of the transmission load reaching consumers.
Right.
We have batteries and solar panels and wind turbines that are operating less efficiently in these
Right.
episodes.
Several good points there on that. You want to add more?
When you have peak demand, the utilities have to draw upon reserve sources that are often higher emitting sources, which gets us back to, it's very important to be thinking about energy efficiency opportunities and really taking advantage of those so that we aren't getting to that peak demand level.
Yeah, that makes sense. What do we do with efficiency kind of demand response in terms of addressing some of these things for resiliency?
I mean, this is a tool that we've been using, again, for decades. And I think we've gotten more sophisticated in how to design the demand response program. And
Before
then,
you go, just tell us what it is.
Sure.
Tell us what demand response means.
Yeah, so the idea is that the utility is in communication with the customer and saying, hey, can you reduce what you're asking of the electricity grid?
You have to run your dryer right now.
Yeah. So sometimes there's incentive programs to not be using electricity during certain parts of the day. For example, in Honolulu, our peak is always at 6 p.m. So, you could design a program where you're trying to get people to not take showers at 6 p.m. because everybody basically uses their hot water heater at that time. And then with electric vehicles, we're going to have a real new demand on the grid. And really need to be thinking about how we're structuring, and demand response programs could be a real solution. There's all sorts of different program designs that are out there, but the concept really is how do you reduce that demand on the grid and that you can really spread the load out over time of day.
Well, let's think about impacts and then maybe some of the policies that that will support adaptation as we go forward. Start with flooding. What are some of the strategies to handle flooding?
First of all, we've been adapting to flooding for a very long time. So one concept that we often think about is adaptation pathways, where we think about adaptation strategies for the near term with a plan to implement a different adaptation strategy in the longer term.
Right.
We have found in Miami that the elevation of roadways has been quite successful in the near term. Overseas in Holland, they've been doing dikes and levees, building them, using them quite effectively for a very long time. There are certain places, Manhattan is usually offered as the example where, we're going to have to use engineered solutions because we cannot move Manhattan. So with those engineered solutions, we need to be thinking about the design of them, but thinking about the design under future conditions. But then there's a whole host of other non-engineered solutions that we can be thinking about, like nature-based solutions, or even operational and maintenance type solutions, and then behavior change. With nature-based solutions, you're thinking about, can we build breakwaters? Can we use natural substances to create barriers, to reduce erosion? So it's often used in coastal areas and quite effectively. So there are good examples out there where many gray infrastructure solutions were tried and failed. And then once we had put in, a breakwater or submerged aquatic vegetation.
Like mangroves or things?
That those were much more successful in terms of decreasing that wave action and really protecting the on-land infrastructure.
Yeah, sure, makes sense. So let's think about policy a little bit and kind of the economics of all this. What policies are we going to need to support this adaptation work?
We need to be doing more of that analysis of what is the benefit of some of these adaptation strategies and what are the costs associated with not implementing, or the costs of inaction, as we refer to it. Because a dollar spent now may result in 2 or many times more savings down the road.
Yeah.
The policy needs to be incentivizing that thinking and then that action as well. And right now, we don't necessarily have policies that do so. We're moving in that direction. So, for example, FEMA, when they come in after a disaster, does not incentivize, building back stronger as much as it could. That is really moving, over the last decade, it's been moving much more in that direction. And those incentives can make a real big difference.
Oh, absolutely.
In terms of how people respond and what they do and how they invest money.
Right. How about from your perspective on that?
I know that we're not doing a great job of tracking the human cost. So we need to pay more attention to the cost of inaction and understand that adaptation investments really make a whole lot of sense, right? And they can help to correct some of the other problems that we are dealing with socially. Mitigation can kind of seem like, a problem where we can't tell if we're making much progress. We don't feel it, we don't see it, we don't feel like we're benefiting from it. Adaptation is different. It's clear, it's local, and it's tangible, and it's immediate, right? We can understand, we can see these things happening on the ground, and we can feel the benefits.
Yeah, I mean, some of the costs that I've seen from credible sources and studies of mitigation for global, running into the hundreds of trillions of dollars, and I just think about that and say, you'd probably like 100 billion of that, right? You could do a hell of a lot of good with that and be very trackable. Let's kind of think about this as we start to wrap up here a little bit. Are there things, let me ask first this question, are there things that we're doing that can make money right now? And then people see the benefit of that, and then we can get the momentum going, get the train started, if you will.
I think we're beginning to see some evidence on that front. For example, we talked about cool roofs earlier. We've done modeling work in India showing that if we expand cool roofs in one city from a current baseline of maybe 5% of roof coverage to 20%, we can actually completely offset the extra AC demand that's going to be triggered by climate warming over the next decade or so.
And there's a cost benefit to that?
Definitely. Cool roofs are a relatively affordable option. We, can also quantify the greenhouse gas and air quality benefits in terms of reduced loads on the energy grid. In India, that's still highly reliant on coal. So there's very clear household level energy savings, but also reduced strain on the grid. And so these incremental actions, these kind of no regrets adaptation solutions can make a dent in terms of people's, lived experience of heat, for example, but also achieve, economic savings at the individual household level and also at the utility level.
Yeah. Are we going to be successful?
I think my concept of success is minimizing suffering. So we absolutely have the tools to minimize suffering. We can do it. We're going to have to invest. We're going to have people understand that their behavior may need to change. But we can, absolutely. And we'll just have to keep at it.
So, good chance for final thoughts. If you wanted to leave our viewers with one or two things to remember, what would that be?
I think that adaptation is really about learning about what we can do to avoid suffering in the future. We know that climate change is intensifying, but we have a choice. We don't need to wander blindly into the future and not take action. So this is about, taking charge of our future and building a healthier, more sustainable, thriving future for all of us.
Yeah, excellent. Thank you. Susan, a couple final thoughts?
Yeah, I think just going back to this concept of being humble and learning from what has worked in the past, recognizing they're going to be different, but that we have all sorts of solutions and maybe some solutions that we haven't really examined that closely. So we really need to be looking back and taking them all into account, getting all the voices at the table who have ideas, whether it's young, old, in different parts of the world, Indigenous perspectives, previously marginalized perspectives. We're going to need everybody.
Yeah.
So we need to really be thinking about bringing everybody into the conversation in terms of developing solutions.
Yeah. Yeah, I like how you both have kind of pulled that into the picture. The options matter, inclusive voices matter globally, and adapting to some of these things, learning as we go, and then being bold enough to say, that didn't work. Let's learn from that and improve and go on to the next thing. So I really enjoyed our dialogue today. Thanks both for being here.
Yeah, thanks for having me.
Thanks, Susan.
Thank you so much.
Scott Tinker, Energy Switch.
We looked mostly at adapting to warmer temperatures, including expanded access to air conditioning, while remembering its greater electricity demand could further stress the grid and produce more emissions. To reduce air conditioning demand, affordable passive cooling could help counter urban heat islands. This could be urban greening, planting trees and building green space, and also using white or reflective materials to create cool roofs. Heat action plans have been successfully implemented in Indian cities and are coming to many U.S. cities to help protect vulnerable workers and students. For areas prone to sea level rise, we discussed engineered solutions like dikes and elevated roadways, and nature-based solutions like breakwaters and mangrove forests. Government policies could include incentives to build more resilient communities. In many cases, these adaptation measures are less expensive than mitigation and more beneficial to those most at risk.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Emily Hooks is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin,